One attachment of atoms that we see in several different types of functional groups is called a carbonyl or a carbonyl compound. And in order to be a carbonyl, we have to have a carbon and an oxygen that are attached together by a double bond. And this is what we refer to as a carbonyl. Now, if we're going to change what that carbonyl is attached to, so that is represented by the question marks in this formula or in this structure, that changes the type of functional group. So one functional group that is possible is if the carbonyl is attached to an OH. Okay? If it is carbonyl and OH, this is a carboxylic acid. One carboxylic acid you might be familiar with, whether you know it or not, is vinegar. So that is acetic acid. And acetic acid has that sour taste. Another one is citric acid from citrus fruits. You get that sour taste, which is a result of this carboxylic acid group. Another type of compound that contains a carboxylic acid is called formic acid. And formic acid, instead of being connected to a carbon, it's connected to a hydrogen. And formic acid is the component in ant bites or bee stings. Okay. If we want to change that group on the carbonyl, that changes the functional group. And so another example of this is an amide. Let me try highlighting instead. So an amide is that carbonyl attached to a nitrogen, and typically nitrogen with two hydrogen, but it could be a nitrogen with one hydrogen. Okay, and that is an amide group. So these are different ways that we have carbonyls, and by changing what it's attached to changes the functional group. So let's look at the following. So determine whether or not there are any carboxylic acids or amides. If they're not carboxylic or amides, state what the functional group is. And then determine the formula. Pause the video while you do this. Okay, so let's look at our first example. So in our first example, we do have a carbonyl, so carbon double bonded to an oxygen, but it is not attached to a nitrogen or an OH. So this is not a carboxylic acid or an amide. It is, however, what we call a ketone. So carboxylic or a carbonyl attached to two other carbon-containing groups. So if we want to come up with our formula for this, we'll count our carbons. So 1, 2, 3, 4, 5, 6. We'll count our hydrogens. 3 off the first, 2 off the second. None off of the third because it already has 4 bonds. 2 off 4, 2 off 5, and 3 off 6. So that gives us 12 hydrogen and also 1 oxygen. If we look at our second molecule, so our second molecule, again, we have our carbonyl, but it is directly connected to a hydrogen. So this, again, is not a carboxylic acid or amide. This is a functional group called an aldehyde because our carbon is directly connected to a hydrogen. So now if we count our carbons, we have 5 carbons. Again, this bond here between the last carbon, carbon 5, and the hydrogen, that is just showing the connection to the hydrogen. There is no additional carbon there. So that would be C5. Because remember, with our functional groups, we have to draw the connections to any hydrogens that are present. C5, hydrogens. So none on carbon 5, 2 on 4, 2 on 3, 2 on 2, 3 on 1, 3 hydrogens on 1. That gives us 10 hydrogens and 1 oxygen. Okay. Our next structure, we again have our carbonyl, but this time it's attached to an NH2. So this is an amide. Have an amide. If we want to count our carbons, 3 carbons. Now our hydrogens, we've got 3 on the first carbon, 2 on the second. Don't forget the 2 in the amide. So this is 7 hydrogens. Now we do have 2 different elements here. So we've got a nitrogen and we have an oxygen to include in our formula. So we want to put them alphabetically. So nitrogen comes first, and then oxygen after that, one of each, so we do not need subscripts. Our last group, we do have our carbonyl, but now we're attached to an oxygen, and this does not have a hydrogen because there's no hydrogen written next to that oxygen. So we have an additional carbon at the end. That means that this is an ester. So it is not a carboxylic acid. This is an ester because there's an additional carbon. So let's count our carbons. 6, 7 on that last carbon. So we have C7. Counting hydrogens. Remember, we need a total of 4 bonds on each. 6 has already has 4 bonds, so no hydrogen there. 7 needs 3 additional bonds, so that's 3 hydrogens. This gives us 14. And in this case, we actually have 2 oxygens, so we need an O2. So we did not have any examples of carboxylic acid here, but we did have one amide in our examples. So a couple of additional common functional groups that we'll see. So notice there is no carbonyl in this case, so there's no double bonded oxygen to a carbon. In this case, we now have an amine. So the ending change, so an amide was when we had a double bonded carbon to oxygen with the NH2. An amine is when we have no carbonyl but just an NH2 group. Okay, so our ending changes to amine. If we look at our second example, so this is an alcohol. Alcohol again, no carbonyl group, no carbon double bonded oxygen, just carbon bonded to oxygen and hydrogen. And again, this is called an alcohol. And at the end of the name, we add an OL to represent that OH group is attached to the carbon. So we've talked about the example of ethanol with the OL. In this case, we have 4 carbons with an alcohol group, so this would be a butanol. So 4 carbons, 1, 2, 3, 4. They're all single bonded, so that's why it's AN. And then the OL group represents that OH that is attached to the carbon.